Well, well, what has the cat dragged in today? It's an introduction to custom inspectors. And I do stress it's an introduction. There's a lot of depth to custom inspectors. I am just covering the bare bone basics of how to do these things. So for context, if you watched the previous video on scriptable objects, which will be linked in the description below, we had created this little stat block of some basic stats, has a display name. And if I look at the orc in the inspector, we've got some problems. One, I can't actually see or edit the stats here. All I can see is that, yes, I have a reference to a scriptable object here. But if I want to change the stats, I have to select the actual asset. I can't do it from the game objects inspector. I also have this calculated health value here that I can enter in a custom value for, which I don't want to have that happen. This is a calculated value. Anything that's put in here will be overridden, theoretically, once the stat is actually calculated, once health is actually calculated. So I don't want designers to be able to input anything here to avoid confusion. Now, for the moment, ignore this demo stat. It's for demonstrating something here in a short bit. Pretend this doesn't exist right now. So I've got some work to do here. I don't want the default inspector, how it's displayed. I don't want that. I need something custom. Hence, a custom inspector. Now, there's a couple of things here. One, whenever you are doing editor code, anytime you are doing something that is in the editor namespace, you are, in most cases, going to want to put that code in the editor folder. And this editor folder can be located anywhere, and you can have multiple of these in a project. It's not an uncommon thing. The reason why you need to have your code in the editor folder is that the editor DLLs are not distributed with a published project. That means if you attempt to include anything that's in the editor namespace, the Unity editor namespace, as you see right here using Unity Editor, anything that's under that namespace is going to cause the build to fail. You cannot build anything that has the Unity Editor namespace in it. Now, any code that is placed in the editor folder is automatically not included with a build. So, since this custom inspector code makes absolutely no sense outside of the context of the editor, that's the behavior I want. I put it in the editor folder. It is excluded from the build. This is sometimes not possible, in which case you have to use compiler directives in order to determine, is this a build or not, and exclude code. And that gets a bit messy and outside the context of this video. Just as a heads up on that. So, custom inspectors, custom windows, any editor-only focused code, you are going to want to put in an editor folder so it doesn't break the build. So let's take a quick look at our code. Pardon me. Take a quick look at the code before we move on. So as a reminder, we've got this mono behavior component in which we have a scriptable object for our stats, because the stats, strength, body, will, are not going to change for any one given category of entity. So if I have 100 orcs in the scene, I would have 100 copies of strength, body, will. I don't want that. I'd rather have 100 references to this data here. But we need to be able to actually edit this in the inspector. And so that is where the custom inspector code comes in. Now, just like the scriptable object, for some reason, there is no direct way to create a custom inspector or direct way to create editor code. So once again, in Unity, right-click, create, C# script, and then change it over from being a mono behavior to whatever it is that you need. Now, there's a couple of important parts here, and I've got a lot of stuff commented out here, so that way it wasn't working for the initial part of the video. The first key part, unless you really like typing in Unity editor dot in front of a lot of things, is that we are going to want to put a using statement in here. Second is that we are going to want to change the inheritance from mono behavior to editor. Our class needs to inherit from editor, not mono behavior. And then finally, we have to inform Unity what exactly is this editor code. And I am going to inform it by the use of the attribute custom editor that this is a custom editor of type of entity. Again, going back here to this. I'm creating a custom editor for entity, not for my scriptable object. I could do it directly for the scriptable object, but in this particular case, I am doing the custom editor for the entity class. If I had, whatever it is that you need to do or create the custom editor for, that's what you would place inside of here. Now, there's obviously a lot more methods than just onInspector GUI, but the method that you definitely need to make this worthwhile is onInspector GUI, because this is the method that actually renders out the information to the inspector window. Notice that this is an override. We are overriding the onInspector GUI method that exists in the base class here. Now, when you do this, it is going to give you a default base call to call back up to the base version of the method. Generally speaking, you are not going to want that. You're going to want to take that out. And the result, if you have an empty onInspector GUI, which is what we currently have right now since everything's commented out, if I hop back over to the editor and I select my orc here, I can see that I still have the component, of course. The component hasn't been removed, but there's no information here. I've overridden the onInspector GUI method, and I didn't tell it to do anything. So, of course, it's blank there. Now, I'm going to uncomment most of this code. I'm going to leave one line commented out, because I need that to demonstrate a point a little bit later on. Now let's go through this line by line. Exciting, I know, that's what we got to do. When you're dealing with editor code, whether it be a custom inspector or a custom window, Unity wants to operate off of this idea of a serialized object. Remember, that's why we can mark a private property on a mono behavior with the serialized property attribute to get it to show up in the inspector but not be editable. So Unity wants to deal with everything as a serialized object. Now, when you're working with a custom inspector, the only way that you can have something showing in the inspector is if you have something selected, and so therefore Unity behind the scenes serializes that selection and gives you a serialized object in the form of this class variable here. This is a class variable for the editor class. So everything that I need to do through this serialized object. The next key part for doing custom inspectors is the use of find property. This serialized object represents this game object here. Or specifically, it refers to this component on this game object, I should say. So in order to do anything with this, I have to find its properties. Of course, the properties are going to be the class level variables that I have in that class. So in this particular case, my properties would be stats, health, and this demo stat, which we will use a little bit later. So I have 3 properties that I can find and use. So what I am doing here is I am telling it to find the property stats in this serialized object and then store that reference here. Assuming that I put in the correct string here, this will never fail. I will always get a serialized property, again, assuming that this property name here is correct. What I'm not guaranteed of is having something in that property. For example, if I come back over here and I look at my Angry Templar, well, if I, hold on, let me remove the custom inspector there for a moment. So if I come back here and look at my Angry Templar, he does not have, there we go, he does not have a stat block referenced yet. So that means when I come through here and I find the property stats, I'm going to find it, but the value that's going to be returned, if I try to do the object reference value, is going to be null. So I need to check for that in this particular scenario. So I am checking to see the object reference value since this is an object that I am finding. If that's equal to null, all I'm going to display is a property field. Now, 99% of the time, when you're choosing GUI layout fields, and you do generally want to be using the GUI layout fields, I'm going to be using them from the editor class because that has all of the property field, label field, ints fields, etc. that I need for the inspector. Occasionally, you will have to go into the GUI layout because there's a few things in GUI layout that you can't find in editor GUI layout because, of course. Property field is what you use when you want to be able to use a picker. So if I make sure this is saved and I hop back over here, and I go to my Angry Templar, you can see that stats, none, and I have a Unity picker that I can use to select his stats. Or I could if something wasn't horribly broken. We'll come back to that point. So that's what a property field does. Now, if this object reference is not null, then I come down here into the main bulk of the work. Since I need to be referring to the stats constantly, I am going to cast this object reference as its actual class, a stat SO, and then store that reference. Do I have to do this? No. I'm lazy, and I don't want to be constantly casting this object reference to be able to get access to the strength, body, will stats that I need. So upon doing that, I use a label field, which is used for text that does not change. And then I use another property field, so that way if I want to, I can change what data is associated with this particular entity. Space just puts a little bit of space in there. And then we come to this strange line right here, which is another core principle, I suppose you should say, of how Unity handles custom inspectors and changing values. Editor GUI layout int field, if you mouse over it, we can see that it has a return type of int. How this works is what you pass into this method sets up what it displays. So by passing in a label and an integer variable, this will be used as my label. This will be used as the value that's filled into the box by default. Now, If I make a change to this, that change is going to be returned out. So the only way that I can actually get a change is by saying variable equals editor GUI layout.int field label, comma, variable. What happens if we don't have that is we will get this behavior. As soon as I click off, it reverts back. No change is made. If I come here and look at orc stats, yep, sure enough, still 15. And I do the same thing with body and will. You have different types of fields, but this particular pattern is followed for most things. You might be thinking, well, hold up, we didn't do that with the property field. And that's because property field's a bit special, because it's using the picker and using some other elements of the Unity editor GUI. It does some things behind the scenes, so to speak, so that this is all that we need for a property field. It's a bit of a special one. Most everything else will follow the pattern of the int fields here. I have space, calculate my stats, do another couple labels to output that information, and I'm done. If I come back over here, let it recompile, select my orc. If I change the body to 25, stays put. Select a different object, come back, still 25. I select the other orc, also 25. Keep in mind, these stats here, these values, they are not stored on these game objects. The values are stored in this asset. You notice the asset now says 25 as well. If I change the asset to 35 and then select an orc, I see the proper values. If I change that back down to 15 and go back and select the asset, it's reflected. So that is something important to remember when using scriptable objects and custom inspectors. These values that I'm manipulating are stored on the asset, not the game object. And that's an important distinction, because that leads us to why I can't set the Angry Templar to Grimm's stats here. In that the value, what scriptable object is assigned to stats, and this particular string right here, oops, that didn't work, did it? But this variable and this variable are stored on the game object, and that's important. Let's go back and look at our code. So your first thought might be, well, are you doing the whole variable equals editor GUI layout.text field thing? Yeah, I am. So this time I need the property demo stat. So I'm calling serialized object, find property demo stat, and I am stuffing that into a reference. So serialized property demo stat equals so on and so forth. I am saying demostat.string value because that's the value that I know is contained in this variable. And I'm going to say that is equal to editor GUI layout.text field label variable. Everything looks good, so why isn't it saving? Well, it has to do with this commented outline right here. The reason why the scriptable object information is saved is because I am directly modifying an asset. It's the same reason why if you are in edit mode in Unity, normally stats get reset. If I change things, I hit go into play here, and I change the orc's X position, and then stop execution, change is reverted. I go into play mode, and I change an asset value, change is not reverted. You will see this same behavior if you're working with an animator controller. If you're tweaking values like triggering things on and off manually in an animator controller while Unity is running in edit mode, the changes will not be reverted when you leave play mode. That's because you are modifying an asset, not a game object. But, like I said, the stats property here, the actual value that we're linked to here, and the demo stat string that I put in here, these are values that are being stored on the game object. These are not values being stored as assets. And so, if I make changes to those, I must remember to apply modified properties to the serialized object those properties were pulled from. So I pulled the stat block from the serialized object here, and I pulled my demo stat from serialized object, and so serialized object is where I have to apply modified properties. You will generally not have more than one serialized object when you're doing custom inspector code, but when doing custom window code, it is very much possible to have multiple serialized objects, so you do need to make sure you track that. And now with that change, let's hop back over here, let things recompile. Ah, there we go. Now it's preserving its value. And to further demonstrate that this is a game object value and not something associated with an asset, if I go to the other orc, value is something. Their values do not impact one another. And now I can come back to my Angry Templar and assign him his stat block. Okay, as much as I like to try to do my videos in one take, there was an error in my code, but it's a good error to have made, and I want to show it. But I did have to pause the video there for a moment, pause recording, to make sure I understood exactly where the mistake was. Okay, so the error that you just saw is that I proudly went to my Angry Templar, attempted to assign him his stats, and nothing happened. But if I come down here to the orc and I change the orc's stats, besides now being guilty of great heresy, it works. So what's the difference? Why can I change the orc's stats, but I can't change the Templar's stats? Well, let's go back and look at our code here. We always have to keep in mind scope. So the orcs, because I had already assigned them a scriptable object, I'd already assigned them a stat block in the previous video, they would fall down into here. And oh, hey, look, here's that serialized object apply modified properties line I was talking about. But the Templar doesn't have anything assigned yet, so the Templar is only going to execute this code. Notice something that's missing in this set of curly braces. That's right. No apply modified properties. No change will be recognized here. We've got two ways we can fix this. I could put the line of code in here, or what I meant to do is have the line there. Now, if I collapse down my if statements, this is what the method looks like. I grab my property, I do my modification stuff, And then as the last line of the method, I call apply modified properties. Always got to be careful about where you put things in relation to those curly braces. And don't get frustrated when it happens. That's the main reason I want to leave this mistake in here. It's a good one to make. It's probably one that you're going to make. And so the key is to always go back and just calmly review your code line by line when that happens. So now that it has happened, and assuming that I actually remember to save my changes, we can finally, at last, assign our stats to our Angry Templar in black. And that is an introduction to custom inspectors. I want to stress once more, this is an introduction. There's a lot of depth here, but this should be at least enough to get you started on writing your own custom inspectors. As always, if you found this video useful, a thumbs up would be greatly appreciated. And if you didn't like it whatsoever, well, there's a thumbs down button as well. See you in the next video.